In this video, we will talk about IP headers. What header information is added at layer 3, which is the network layer. So first of all, we'll look at the IP header format. How does the IP header look like? Typical size of an IP header, it varies between 20 to 60 bytes. This is the format of IP header. It has version, header length, type of service, total length, identification, IP flag, fragment offset, TTL, protocol, header checksum, source address, destination address, IP options. We will cover only the most important information from here. For example, version. So version for an IPv4 is set to a number 4 here. This is only applicable to IPv4, not for IPv6. So whenever you are dealing with IPv4, you'll see this version field set to number 4. The type of service, this is used for QoS, quality of service. QoS is kind of feature that allows you to give special treatment to some packets. For example, you can apply QoS to prioritize voice traffic, so the voice or video traffic can take preference over anything else. That is done by applying QoS. Then we have total length. So this total length field, it tells how much is the entire size of the IP packet, which means including header plus data. So again, similar to TCP header, each of these row, they are of 32-bit. 32, 32, 32, 32. So identification. If the packet gets fragmented, then each fragmented packet will use the same identification number to identify that which IP packet those fragments belong to. So all the fragments of the same IP packet will use the same identification number so that they can be reassembled. Right? So their identification number will be same. Then we have IP flag. So there are mainly 3 flags here that we'll be dealing with. The first bit is always set to 0. Then we have DF, which is don't fragment. So if DF bit for any packet is set to 1, so that packet is saying that do not fragment me. So that packet will never be fragmented because its DF bit is set to 1. So even if that packet is exceeding the size, it will not be fragmented. Maybe the packet size is 1560 bytes, but the interface MT is 1500 and DF bit is set, that packet will not be fragmented. So what will happen if not fragmented? It will be dropped because it exceeds the maximum transmission unit of the interface. Then we have MF, which is mode fragment. So when MF bit is set, it means that basically there are more fragments to come. So if MF bit is set for some packet, it's telling the receiver that there are more fragments to come, right? So MF bit will be set for all the fragmented packets except the last one. So let's say these are the fragmented packets. All of them will have the MF bit set to 1 except the last one. So last one will have MF bit set to 0. This means this is the last packet. This is the last packet of the fragmented IP packet. Then we have fragment offset. So fragment offset is a 13-bit. It's a 13-bit value. This basically points to the position of the fragments in the IP packet. That where are those fragments? Then we have TTL. TTL is an 8-bit value. TTL is time to live. Every time an IP packet moves through a router, the TTL value is decremented by 1. Then we have protocol here. It tells you that which protocol is being encapsulated by the IP. What is the underlying protocol? Because this is the packet is coming from the layer above it, right? Right now we are looking at layer 3, but then it came from layer 4. So in the layer 4, what was the base underlying protocol? TCP, UDP, or anything else? So what protocol is getting encapsulated by IP here? So that protocol information will be displayed here. If it was TCP, then it will say the protocol number for TCP, which is 6. Then we have header checksum. So this will check if the IP header was okay or not. Then we have source IP address and destination IP address. So this is where the layer 3 will add the source and destination IP. As you know that source and destination IP, they both are 32-bit numbers, right? And then we have IP options. So this is not really used very often. And then you will have actual data if there is any. So that is all about the IP headers.